Hi, my name is Amit. I'll be talking about Android mainline tracking kernel. People who don't know what this kernel is, we rebase Android patchset, latest Android LTS patchset to upstream kernel. Now this talk, this talk is a streamed down version of the talks which I have done earlier, where I've talked about Android out of tree patchset, and I briefly cover Android mainline tracking tree as well. So I won't be covering the complete patchset. So I have put down a link here where you can find my last set of slides which I have done on this topic. Similarly, I will not be talking about Android common kernel. Source.android.com has this detailed description of Android common kernels, how it is being derived from LTS trees and Android LTS kernels and Android desert kernels, and why you should use Android LTS versions instead of Android release versions, desert release versions. Okay, I won't be talking about EAS tree as well. There is a talk on Thursday where EAS developers will be giving an update on current set of EAS patchset, Android patchset, and their mainline status. Right, so I'll just start with the main topic of the day, Android mainline tracking kernel. Now, why do we need this kernel? Or what exactly is Android mainline tracking kernel? As I mentioned, this is Android LTS patchset rebased to upstream kernel. For example, the current snapshot which we have is based on 4.19 RC2, which is Android 4.14 patchset rebased to Android 4.19. LTS versions, they get tagged as Android LTS release. For example, when we did 4.13 based trees, so the next LTS, which was 4.14, we tagged that thing as Android 4.14. Similarly, hopefully the next one will be Android 4.19. Non-LTS kernel versions, they get relatively feature testing on DB410C locally, and then we tag it as experimental Android tags, 4.17, 4.18, etc. Right, so why do we need Android mainline tracking? So the main purpose of coming up with a tree like this was to find upstream regressions, to see if the Android patch sets are, when you rebase it to newer kernels which our members used to do earlier on their own, right? So these upstream regressions were not reported to upstream at that time. So we used to report these regressions in the next LTS versions. So by doing this tree, by testing this Android mainline tracking kernel, we find and report regressions within a week, and they get fixed in the same release version, instead of waiting for the next cycle or next to next cycle. This tree is used as a test tree for few patches which have been currently under development and are not actually submitted upstream. These trees are used as experimental or reference kernel trees for our member partners. This is the most important thing which I wanted to cover, that before this, there was no easier way to do that, right? Now we have a reference or experimental preview tree which our members can quickly download and get started for their upcoming SoCs. So this is the stat on 4.19 and the current mainline tracking tree. If you compare it with the earlier versions, you can see a big difference of the delta, which I will which I'll talk about in next slides. So just a brief description here. SD card FS is now the biggest chunk of code which we are carrying. A lot has been dropped from netfilter, but it is still one of the bigger chunks. Now the usual suspects, USB gadgets and input drivers and other things. Right, so I have compiled down a list of 4 or 5 features which have been recently added compared to 4.14 or maybe 4.9, or something which has been recently added like 2 or 3 months ago. Right, so we'll start with PPP. So Android used to have a legacy OP, NS, and OLEC drivers, which were completely out of mainline. These patches got dropped in 4.14, right? But they got dropped in favor of upstream kernels or upstream drivers in the kernel. And Sam has done a lot of work to make sure that upstream drivers can work as efficiently as the legacy Android drivers, which were not there in 4.14. Now, recently, all those changes, which was spread across MTPD, PPD, and other projects, they got merged into AOSP. So now AOSP can use these upstream drivers, PPTP and L2TP. I think they still coexist with the older legacy implementations. There's a check somewhere where if you want to use the legacy drivers on 4.9 or 4.4 kernel, you can still do that. But on 4.14 onwards, you have to use upstream drivers. Sam is giving a talk on this on Friday afternoon. So if you want to learn more about how to use these upstream drivers and what all changes he has done to make sure that the AOSP uses those upstream drivers, you can attend this talk. So the second feature which got added recently was Clang control flow integrity support. If you check the Get review, you'll find that it got added with LTO, which is a link time optimization support. LTO got dropped, and if LTO was not really, there were a lot of merge conflicts because there are a lot of changes which went into LTO in the upstream driver. And later we found out that we don't need Clang LTO support anymore. So and I have not listed down those patchset here. So this is the new thing, control flow integrity support, which kind of provides restriction or which enforces certain restrictions on a control flow of an application so that your application goes through a valid execution path instead of just leave something which can be later exploited by something else. I have put on a link of Gerrit topic, which lists down all the patch set which goes into this particular set of patches. So you can find it here. Right, so the next thing is qtaguid. qtaguid is again a big set of chunk of code which is currently sitting in Android kernels. The plan for this, so the qtaguid is used for data counting and sort of data limiting. It tracks the socket usage and data usage. Right. So in last LPC there was a talk on how you can use qtaguid with eBPF C group filters. I've listed down a link here from last talk, from the talk from last LPC. This patch set is still in Android mainline tracking tree because there are a couple of user space dependencies which are still using qtaguid. So we are hopeful that maybe by the time 4.19 gets released, we should be able to get rid of qtaguid patch set. Right, so these are the patches which are recently got added or something which are going to be replaced by something else. Now these are the patches which I'm going to talk about are the patches which are no longer required in AOSP, so we dropped it from 4.18 or we might drop it in 4.19 as such. First one is FIQ debugger. It's a big chunk of code which finally is going away because there are no users, no vendor users or no users for FIQ debugger driver anymore. Second set was Goldfish drivers. Most of the development of Goldfish have moved to upstream, so there was no point on keeping hacks in the Android common kernel as such, so we dropped Goldfish driver as well. Keycode input driver, it got replaced by a user space daemon. So in kernel driver is again something which is no longer required and we can just delete that. Actually we deleted that. I have put down a link of the user space functionality which replaces this kernel driver for reference. Then there were a few tracing out of tree patches, which most of them got upstreamed, and whatever is left behind are in the process of getting upstream. Again, there were few patches which were no longer required. There were a few GPU tracing patches, and there was one more patch that I'm not functional graph something was there which is no longer required. So we dropped those patches as well. Then there were a few MMC hacks and hooks, few hacks which will retry the MMC detection, and MMC SDIO support was there, which no one else is using nowadays. So since there were no users for these patches, that MMC SDIO driver, we removed this MMC hacks as well. USB OTG wake lock is again something which we rely on upstream drivers now. Same thing with dual sysfs interface. So these patches got removed from the mainline tracking tree because they are now being superseded by upstream implementations. Then there were small hacks and workarounds. Most of them were toolchain specific workarounds and device specific hacks, which were no longer needed with 4.9, 4.18 and newer kernel versions. Then there were a few debug hooks, few patches which will dump the memory registers for debug purpose. There were a few ARMv6 specific debug hacks which are no longer needed. So all those patches are no longer part of Android mainline tracking tree now. Right, so last but not the least is the renewed upstreaming effort which we see on AOSP Gerrit nowadays. All right. So if you follow Android Gerrit as much as we do, you will find out that the kernel team is taking more upstream friendly approach when it comes to Android common kernel development. I've missed out the LTFT part because that is something which should be a part of this as well. So as I was talking about the Gerrit tree, right? If you see the Gerrit reviews and you see that there's a new patch set which is being added there for review. So you'll find that Greg will automatically reply on that, okay, see this should not be submitted here, it should go to relevant upstream mailing list for review first instead of being there on Gerrit only. Same thing with stable kernels as well. If you try to push a patch, upstream patch to older stable kernels, then again you will get the same warning from Greg that the correct thing to do is to do it through stable mailing list. The second thing is that Android patchset is, again, as I have mentioned, that all those patches which got dropped recently and submitted upstream. So that's a part of this whole, I think, all this Android patchset cleanup which might be going on internally. All the patches are being reworked and submitted upstream. So all this I have covered, right? All the device-specific hacks and all these workarounds are again being dropped. And non-upstreamable features are being worked upon to move to user space. As we have seen in the case of keycode driver, you can take an example of MTP and PTP, which were there for a long time, and upstream did not like the implementation. They said, so they were kind of hoping that it should move to user space, and eventually it did. So, all right, so I think that's a whole part of this renewed upstreaming policy which is currently being going on. That's pretty much it from my side. Do you have any questions? Wow, 15 minutes. Sorry.
So based on expect these different things, when do you think that we will be able to run a mainline kernel with Android? When we will be at the same level, so we can mainly just use the mainline kernel or merge that?
Actually, right now you can boot to UI with most of the things working.
So as you said, you can boot to UI with mainline,
Yeah.
but it's kind of crashy and hacky. And this is going to be a focus of next year, is to try to get with the. So we kind of consider most of what's left as technical debt, and the prioritization of the technical debt will be to get solid UI boot with mainline kernel. So that's what we want to get to sometime over the next year.
Great.
Okay, if there are no more questions, then we can just wrap up. Thank you.
All right. Thank you, Amit.